I'm Anil Kumar. Welcome to my series on circle. We are going to discuss relation between arc length and sector area in this particular video. The measurements for the angle will be done in degrees. Here are 5 related questions. We'll definitely begin with a general formula derivation and then answer these 5 questions. Question number 1 is, find the length of an arc which subtends an angle of 120 degrees at the center of the circle with radius 10 centimeters. Question number 2. Find the perimeter of the sector of an arc which subtends an angle of 160 degrees at the center of the circle with radius 10 centimeters. Question number 3. A sector of a circle of radius 8 cm has an area of 28 cm square. Find the angle subtended at the center of the circle. Question number 4. The length of the minor arc AB of a circle O is 3 pi cm and the length of the major arc is 9 pi. Find the radius and acute angle AOB. The last question here, question number 5 is, the length of an arc of a circle is 10 cm. The corresponding sector area is 50 cm square. Find the radius of the circle. So all these are related questions. We'll begin with derivation of the formula which relates them, apply the formula, and then find the solution. You definitely need a calculator for all these calculations. You can also pause the video, answer, and then check with my solutions. So let's begin with the general understanding of arc length and sector area, right? So let me just sketch a circle here, and then we'll define our terms. So that is the circle, and in this circle, let us say that the radius is R. And the angle subtended, when we say, that's the center. Name of the circle is given with the center itself. This is the radius, and that becomes a sector. Do you see that? So we can name this circle, let's say O. So the name of the circle becomes O, which is the name of the center itself. Now that is the radius, length R. This is R. The angle subtended at the center is this theta, right? And the arc length is what we are talking about. Let's call this as L. So this is the arc length. Right? And the portion here, which, let's say if you cut it off, we call this area as a sector. So in this video, we are going to relate all these things mentioned here. The relation is kind of simple. Let's begin with a circle itself. So in a circle, what is the circumference? Well, the circumference is 2 pi r, correct? The circumference is 2 pi r. Now, in a circle, full circle is how much? Full circle angle. Well, full circle angle is 360 degrees. Now, what are we interested in? We are interested in arc length for the angle theta, correct? So it has to be a ratio of that angle to the full circle angle, correct? So basically, it is theta over 360, which is the full circle angle in degrees, times 2 pi r. Does it make sense to you? So that is how you can actually derive the formula. Perfect? Okay. Now let's talk about area. So what is area of a circle? We can also denote circle with this symbol, right? So area of a circle is pi r square. Now, can you tell me the area of sector? Not difficult, same ratio, correct? Which is theta over 360 degrees times pi r square. Is that clear to you? Perfect. So these are very important relations, simple to remember. I am not simplifying this because then it becomes slightly more difficult to remember. Now you don't have to remember. It is a concept. If the angle is smaller, we have a smaller area and smaller arc length. And it is in the same ratio as the ratio of the angle theta itself. Do you see that? So I hope this concept is absolutely clear. Now that should help us to find solution to all our questions, correct? Now from here, there are few important things which you can also correlate. That is to say, if I want to know what is the relation between area of sector and arc length? Well, what is the ratio of area of sector over arc length? Well, the area of sector formula is given to you right there. Let me place this here. Theta over 360 times pi r square. And the arc length is theta over 360 times 2 pi r. Now it is much simpler. We can cancel theta over 360, right? We can cancel this pi also and one of the r's. So what do we get? A very simple formula, and that is equal to r remains in the numerator over 2. Do you see that? So area of sector over arc length is half of the radius. Do you get it? This is a very important formula, especially when you are doing complicated questions and a multiple choice complicated question. You have a straight formula to find the answer, right? So I hope the general formulas are absolutely clear. The arc length for an angle theta, I should written right here, arc length is always given L, right? So L is the symbol for arc length. And for area of a sector, we will say area of a sector with A and subscript S. Is that clear to you? And we also figure out that area of sector over arc length for the same angle and radius will be half of r. Okay, now let's begin to solve our questions one by one. The very first question here is straight application of the formula. Find the length of arc which subtends an angle of 120 degrees at the center. Let's make a sketch. Okay, we want 120 degrees at the center. So it is an obtuse angle, right? So it is 90 plus 30. Find the length of the arc length subtended by this angle of 120 degrees at the center of a circle whose radius is 10. Perfect. Let's call this circle O. That means this center will be O. So arc length L will be equal to this angle theta over 360. It is the ratio, right? Full degree to this times 2 pi r times 2 pi r the circumference. Now we are given all the figures, right? So we are given theta as 120 degrees. We are also given that r is 10 centimeters. And therefore, we can now write down this value as 120 degrees over 360 degrees times 2 pi and the radius 10. Is that clear to you, right? Now we can easily simplify this to get our answer. 12 goes 3 times, right? And therefore, we have the answer here as 20 over 3 pi. So that becomes the exact value. So if you want the exact answer, this is what you have to write. So this is the exact value. And the units are, of course, centimeters. But let's now write it approximately. So we have 20 divided by 3 times pi. So in decimals, it is 20.94. Correct? So we could write this in many different ways. Let's look into this. So one, we could approximate this and we can write this as 21.0, right? Now that answer which we have mentioned here is 1 decimal place. Is it clear? That answer is to 1 decimal place. Is that clear? And the units are centimeters, right? So that is how you're going to answer this question. So I hope the concept, the formula, and how to approach is absolutely clear. Now you should be in a position to answer the rest of the questions. Here is the second question. You can pause the video, answer this question, and then look into my suggestions. Question number 2. Find the perimeter of the sector of an arc which subtends an angle of 160 degrees at the center of the circle with radius 10 centimeters. This question is very similar to the previous question. So you can always pause the video and answer this question, right? We'll try to answer it in this fashion. So let me just sketch to explain the concept. 160 degrees, so it is slightly less than the straight line, right? All my diagrams are approximate, but they make a lot of sense, right? Now, we need to find the perimeter of the sector. The perimeter means we have to find this arc length and add this to the radius. Do you understand this? So, in a way, it is similar to previous question. So, let's first find the length of the arc, L, and these are our radius. We are given that the radius R is 10 centimeters, right? The angle theta is 160 degrees. The arc length L is equal to the ratio theta over 360 degrees times 2 pi r. In our case, the angle theta is 160 divided by 360 times 2 pi, and the value of r is 10. So we'll find r first, right? So let's use calculator to calculate this. So we have 160 divided by 360, right? Times 2 times 10. Okay. Now we'll do times pi and write down its decimal equivalent. This is equal to 27.925. That's what, right? The units will be centimeters. So we get the value of L. Now, as far as the perimeter is concerned, it is important to note that we have to add these two sides also, right? So perimeter of sector will be, think like this, right? So the perimeter of the circle is basically, we're talking about this piece of cake. Do you understand? Now we found that this length here is, we can approximately write this as 28.0, and these lengths are 10, right? So the perimeter is sum of three sides, so it is 10 plus 10 plus 28.0. Is that okay? So it is 20, so 48.0, the units are centimeters. Perfect. We rounded this to 28.0 centimeters. Is that clear to you? So when there is a question about the perimeter, you have to add the two radii with the arc length for the sector. Question number 3. A sector of circle of radius 8 centimeter has an area of 28 centimeters square. Find the angle subtended at the center of the circle. Right. So we'll just draw a circle, and we are saying that we know the area. So this time we are given the area of the circle. Earlier we were trying to find the area itself, correct? The radius is 8 and the area is given to us, right? So the area of sector is given to us as 28 centimeters square and the radius is 8 centimeters. Find the angle, right? So the formula for area is the angle theta over 360 degrees times 2 pi r, and that should be equal to 28, right? Now from here we can find the angle by cross multiplication, correct? We know all the figures here. So angle theta is equal to 28 times 360, right? So we'll write within brackets 360. And we're going to divide this by 2 pi r. 2 pi and the radius, which is 8. Is that clear? Since r is equal to 8, right? So we replaced r with 8, right? So that is how we could easily solve this particular question, correct? So if you want, you can simplify here. Otherwise, use calculator. Is it okay? So there is no harm. Just use calculator. So we have this divided by 2. 4 goes 90 times, and that goes 7 times. So if you need exact values, I mean pi is in the denominator. In terms of pi, you can always get the value, right? However, we'll do our calculations. So when you're allowed a calculator, I'd like you to straight away use the calculator, right? So we'll use 28 times 360, divide by, we'll do 16 first, and then we are going to divide by pi itself. We get 200.53. Correct? So to one decimal place, I could write this answer as 200.5 degrees. So that is my answer at one decimal place. Is that clear to you? Right? So it is definitely not what I have drawn here. Right? So that is the answer. So I hope the steps are absolutely clear. Right? So now let's move on and take the next question, which is question number 4. The length of a minor arc AB of a circle O is 3 pi centimeters and the length of the major arc is 9 pi. Find the radius and the acute angle AOB. Okay. So minor arc means smaller angle, acute angle, correct? So we are saying this is the minor arc, which is 3 pi. And that is the major arc, which is 9 pi. Correct? So that is the minor arc. And the rest is the major arc. Do you get the idea? Correct? You need to find the radius. Well, circumference is sum of minor arc and major arc lengths. Clear? So circumference is 2 pi r, and these two are given to us as 3 pi plus 9 pi. So we get 2 pi r as equal to 12 pi. Well, pi and pi cancel. Oh, sorry, pi and pi cancel. And r is 12 over 2, which is 6. The units are centimeters. So therefore, we have our answer, radius equals to 6 centimeters, right? So we have r as 6. So that is one part. The second part of this question is to find the acute angle AOB, right? So that is the arc AB, the circle center O. Now let's find what is the acute angle AOB. So this angle we have to find, let this be angle theta, correct? We know the radius and we know 3 pi is the arc length. So to find this angle, we can say it is 2 pi r over this. So we'll use this formula right there. Let's do it on this side. So the arc length L is 3 pi, which should be equal to the angle theta over 360 times 2 pi r. We know what r is, so we can find what theta is, correct? So theta is equal to, let's just cancel a few terms, which just to simplify, right? Okay, so theta is equal to 3 times 360 divided by 2 times r, and r is 6, right? So it is 3 times 360 divided by 2 times 6, which is 12, right? So it goes 3 times 30. And so we get theta as 90 degrees. Perfect. So we get the angle AOB equals to 90 degrees. Does it make sense to you? Correct? You could have found the angle even otherwise in this particular case, right? Since now you see it is 1/4 of the whole circle. Total circumference is 12 pi, 3 pi is 1/4, right? So the ratio is 90 degrees, right? So that was an alternate method. So let me write down the alternate method. So we know this angle theta over 360 degrees will be equal to 3 pi over total length, right? Which is 3 pi plus 9 pi. Do you see that part? So from here, you could get your value of theta, right? Cross multiply, this is 12, so 1/4 of 360 degrees. So this alternate method is a shortcut to solve such questions. Perfect. Now, we are in the last question, which is a thinking question. I'd like you to pause the video, answer this question, and then look into my suggestions. Question number 5. The length of an arc of a circle is 10 centimeters. The corresponding sector area is 50 centimeters square. Find the radius of the circle. So we know the length of an arc, L, is 10 centimeters, right? This is arc length. And the area of sector. Corresponding sector area, so area of sector. Let's say A of sector is 50 centimeters square. We need to find the radius of the circle. That is the question for you, right? So how are you going to do it? Well, one, you know the relation between the area and the arc length, right? So area over the arc length is r by 2. So that should give you the formula and the answer. Very simple, right? So we get the values from here directly, right? So you could use the values here, which is 50 over 10 equals to r over 2, and that gives you, that is r equals to 10. Is that clear to you? So that is definitely a shortcut, very easy way of finding this out. And of course, the other method is, we'll relate the two, right? So area of the circle, sector area will be theta over 360 degrees times pi r square, right? And length is theta over 360 degrees times 2 pi r. So, since we need to find r, we have to cancel the other terms. We don't know the angle. There is no need to find the angles. Do you see that? So, let's say this is our equation number 1, this is our equation number 2. So, we do equation number 1 divided by equation number 2. So, we get area of this sector over the length is equal to theta over 360 degrees, just as we derived earlier, pi r square over theta over 360 degrees times 2 pi r. So we are going to cancel the common terms, right? The pi's and one of the radius. And what we get here is our formula which we used, which is r over 2. Now I'll substitute the values just as we did earlier, right? Area is given to us as 50. Length is given to us as 10 centimeters. And radius is what we need to find. So which is just 5. So r over 2 is 5, and that means 5 times 2, which is equals to 10, is the value of r. So we get our answer, r equals to 10 centimeters. Perfect. So with this, I hope you have understood all the concepts and you are in a position to solve any question which relates to arc length and sector area. So in this video, we focused more on the angle in degrees. You can always work in radians also. So we have another video on radians. However, I hope that helps you to understand all the concepts. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'll be great. Thanks for your time and all the best.